Section 11.3 is on simplifying rational expressions. A rational expression is a fraction with a polynomial in the numerator and a polynomial in the denominator, and the denominator cannot equal 0. In the last section, when we were looking at graphing rational functions, we found the excluded value for the rational function. You can also have excluded values for rational expressions. And remember what that is it's the value of x that makes the denominator 0. So here's a couple examples. So I have, my first example is 3x over x squared minus 4. So since x squared minus 4 is in the denominator, that cannot equal 0. So I would just kind of set it not equal to 0. Now x squared minus 4 can be factored. Remember, that's a difference of squares. That's x plus 2, x minus 2, cannot equal 0. So that means that x plus 2 cannot equal 0, and x minus 2 cannot equal 0. So x cannot equal a negative 2. There's one of my excluded values. And x cannot equal a positive 2. So my two excluded values for this first expression are positive 2 and negative 2. Let's look at our second example. 7 over the quantity 3ab squared c. Notice there's no plus or minus in here, and so to factor this, I would just kind of factor it down into a 3, an a, 2 b's, and a c. There isn't a whole lot of work to show in this because any value of a, if a is 0, the whole denominator is going to be 0. If b is 0, the whole denominator is 0. And if c is 0, the whole denominator is 0. So my excluded values are a cannot equal 0, b cannot equal 0, and c cannot equal 0. Because if any of those variables are 0, then the whole denominator is 0, and you can't have that in a rational expression. To simplify a rational expression, you need to factor it if possible, and then cancel any common factors in the numerator and denominator. And I always like to follow my own little rule here. You can only cancel stuff that's being multiplied. So if I have an x minus 2 on top and an x plus 2 on the bottom, I cannot cancel those x's because they are not multiplied. Let's take a look at a couple examples here. Simplify each expression and state the excluded values. So here I have 28ab cubed over 16a squared b, and I think we've done examples like this before. We have no addition or subtraction, it's all multiplication, so I can just go through and cancel my coefficients, my a's and my b's. 24 over 16, 4 goes into both of those, so this will become a 7, and this will become a 4. I have an a over an a squared, so 1a on top cancels with 1a on the bottom. I have a b cubed on top and a b on the bottom. The 1b on the bottom will take out one of those on the top and leave me with a 2 there. So my final answer, on the top I'm going to have a 7b squared over 4a. That's my final answer. My excluded values. Now you might just say it's just a is not equal to 0 because that's what's on the in the denominator. But I actually need to go back to my original expression and notice there was a b in the denominator. So another excluded value is that b cannot equal 0. Okay, let's take a look at our second example here. 5x plus 15 over x squared minus x minus 12. Let's factor the top and the bottom. Oh, here's what I was saying about you can only cancel stuff that's being multiplied. At first look, you might say, well, here's an x, and I can cancel that with this x here. But this x is actually being multiplied by 5 and added to 15, and this x is being subtracted from x squared and some other stuff going on down there. The other thing you can't do is you can't cancel the 15 and the 12 by taking a 3 out of each of those, because those are actually added and subtracted from other values in the expression. So first thing I need to do is factor. On the top I can take out a greatest common factor of 5, and that's going to leave me with 5 times x plus 3. And on the bottom I have a trinomial to factor, so I'm looking for two numbers that multiply to negative 12, and the same two numbers have to add up to a negative 1. So that's going to be an x minus 4 and an x plus 3. Now that my expression is completely factored, Now I can cancel out any common factors on the top and the bottom, and that would be this x plus 3 and that x plus 3. So my final simplified expression is 5 over x minus 4. And now I need to state my excluded values. To do that, I need to go back to my original denominator. And my original denominator actually factored into an x minus 4 and an x plus 3. So x cannot equal 4, because that would make this 0. And x cannot equal a negative 3, because that would make this a 0 as well. Even though I canceled out the x minus 3, I still have to include that as a possible way of coming up with my excluded value. And the last thing we're going to take a look at here is something called the zeros of a function. The zeros of a function are the values of x that make the whole function, that is f of x, equal to 0. For a rational function, this happens when the numerator equals 0. Notice back here when we were looking for excluded values, we were basically setting the denominator equal to 0. Now if we're looking for if we're looking for the zeros of a function, we're going to take the numerator and make that equal 0. So here's an example. It says find the zeros of the function f of x equals x squared minus x minus 12 over x minus 2. This time, I really don't care what's going on with the denominator. I'm just going to focus on what's going on top. So I'll take my numerator, x squared minus x minus 12, make that equal 0. Because remember, what I want is what are the values of x when the numerator equals 0. And as we saw in the previous example, this factors into an x minus 4 and an x plus 3. So x minus 4 equals 0, x plus 3 equals 0, x equals 4, and x equals negative 3. And these are the zeros of this function. Those are the values of x that when I plug those in, f of x will equal 0. Another curious thing is if I were to graph this whole function, this is where the graph would cross the x-axis, at the points x equals 4 and x equals negative 3. So looking at simplifying rational expressions, the main thing we need to do is remember how to find the excluded values, set the denominator equal to 0, and those are the values that x cannot be. When we're simplifying a rational expression, we need to remember to factor first before we do any canceling. And then in order to find the zeros of a function, we're going to take the numerator, that is the top of the fraction, and set that equal to 0 and find those two values of x, because that's where the graph of this function would cross the x-axis.